Welcome to PSLE Maths, where you find solutions to PSLE math problems. Please subscribe to this channel and press the bell icon for notification. Thank you.
Hello kids. Earlier in part 1 of the pattern problem tutorial, we have seen how to derive formula for pattern problems with constant difference. Now let's look at pattern problems that have square numbers. So let's look at this pattern where we have figure number 1, 2, 3 and 4 is given. Pattern 1 has 1 square. Pattern 2 has 4 squares, pattern 3 has 9 squares, and pattern 4 has 16 squares. So this is clearly n times n. So the nth figure will have n times n. This is also known as n square. So if the question was how many squares would be there in pattern 10, the answer would be 10 times 10, which is 100. Here we have taken an example, pattern 31. If the question was how many squares would pattern 31 have, the number of squares would be 31 times 31, which is 961. So these are square numbers. Sometimes it could be straightforward as this, and sometimes we could have something slightly different. Rather than giving the straight away the square numbers, we could be given 2, 5, 10, and 17. Look at this new pattern. Pattern 1 has 2 squares, pattern 2 has 5 squares, pattern 3 has 10 squares, and pattern 4 has 17 squares. Now that we have already seen n times n, looking at this, we straight away know this is one more than the square number. But even if we do not know the square numbers, just by looking at the pattern, when we see a difference which is increasing, we don't see a constant difference. Between 2 and 5, the difference is 3. Between 5 and 10, the difference is 5. Between 10 and 17, the difference is 7. So it is the difference itself is increasing. That is not a constant. It's increasing as 3, 5, 7. Next one would be 9. So those numbers, whenever you see here, the difference increasing, it would mostly be square numbers. So if this is given, you know that 1 corresponds to pattern number 1 will have 1 square. So anything that is excess would come as plus 1 in the formula. So this pattern is n square plus 1. So given this pattern, if the question was which square will have 290 squares? Which pattern number would have 290 squares? So we just have to equate n square plus 1 is equal to 290. N times n should be 289. So n is equal to 17. So pattern number 17 would be the answer. Now let's look at another pattern. So here we are given as the figure 1 has 2 squares, figure 2 has 8 squares, figure 3 has 18 squares. So fill in the blanks for the figure 4. We see the increase from 2 to 8 is 6, 8 to 18 is 10. So that's again not a constant increase. The increase itself is increasing. These again, even if it is not directly a square number, we can see how we can relate it to a square number. In this case, 6 increase, the next one is 10 increase, which is 2 times 5. First one was 2 times 3, 2 times 5. The next one would be 2 times 7. So 14 increase. For figure 4, the number of squares should be 32. So what are these basically? These can be written as 2 times 1, 2 times 8 is 2 times 4, 18 is 2 times 9, and 32 is 2 times 16. So nth pattern will have 2 times n square. So here again an example, which pattern number would have 338 squares? So we have to again equate 2 times n square is equal to 338. n times n would be 338 divided by 2, which is 169. So n is equal to 13. So pattern 13 would have 338 squares. So whenever we see an increasing number between the difference itself is increasing, we can check out if the pattern is following a square number pattern. So hope the square number is understandable. In a subsequent video, we will look about triangular numbers.
Hope you like this video. Please subscribe to this channel for more problem sums. If you have a specific question that you would like to see a video on, please post it in the comment section. Thank you.